All right, so this is the program for the motion sensor again, and you're going to open the serial monitor, um, type start. Then I'm going to place my object on my incline. In this case, I'm going to be using the candle, which is my solid cylinder first. Like I said, the cylinders should be easier to get data for than the spheres. I'm going to show you both, and hopefully what will happen here is that I get pretty good data for the cylinder, and then the sphere, it may cut out some, and if I get something that's somewhat usable uh, fairly quickly, I'll just show you that. Otherwise, I may, do a few off camera and show you uh, what to do if you get something that's bad but still usable. Anyway, for the cylinder, I'm just going to put that on my incline, hit start, release it, it will roll down and stop. And so this will be an example of what your data will look like if it works. At least it looked like it worked correctly. So you can see at first it was at 17.37 centimeters most of the time. I mean, it will fluctuate a little bit while you're holding it stationary, but this is all while I'm holding it stationary. Then somewhere around here, it starts to increase after I've released it. It increases, it increases, it increases. And it looks like at this point it cut out because you can see it jumps from 0.85, so 85 centimeters or 86 centimeters to 142 centimeters. So that means it cut out at that point. But everything before that is plenty usable. And then you can see after that, it just it bounced around some, but it's at that point recording something beyond my my incline because the object either cut out or like the sensor cut out from the object, or the object went off the end of the incline or whatever. So what I'm going to do here is select all of the data before that cutout happened. You can also just select all of it and then only use the data that's good once you go into your spreadsheet. I'm just gonna only select the part of the data that I want and copy it. I'm gonna go over to a spreadsheet. I'm gonna paste it. And then when you paste it, it should give you this option. You want to split text into columns. And it will use the fact that there's a comma to assume that those should be separate columns. So now what I want to do is make a graph of this data. So just going to insert a chart. Want a scatter. Actually, I'll just cancel that. So for the x-axis, I want time. For the y-axis, I want the position. And it gives us our data. Now, we can see that in this case, I didn't have the sensor cut out during this section of good data that I got. If the sensor does cut out, you'll see points that spike off the graph. And the best option is actually to just delete those points if they occur, if you only have a few of them and your data is mostly good, because those are just bad data points. Otherwise, if you don't have any bad data points like that, you can just plot it like this. So now, though, really what we want to do is only look at the part where it's accelerating. So if I look at my data, it was stationary until somewhere in this area. So I want to start at, I'll say, the 17th cell. So I'm going to actually make a second graph for this. So I'm just going to copy this and paste it. And we're just going to start at 17 here. And $17 here. And so that is a graph of our data for only the parts that are where the cart was accelerating, or not the cart, the candle was accelerating. So now we need to determine the acceleration from this. And how we're going to do that is just by having the spreadsheet fit this. So in Google Sheets, you go to series, trend line. We want a polynomial, second degree polynomial. Because as we should know by now, for constant acceleration, the position versus time is a polynomial, or a second degree polynomial, and the term associated with the squared of time is the acceleration, or is actually half the acceleration. So we want to use the equation, and obviously you'll want to add titles and axis labels and things. So anyway, so you'll have something like that. And so our acceleration is just twice this x squared term. So we would record for this our acceleration well, we'll just do 2 times 0.18. And so you'll want to compare that acceleration to the theoretical value. So now we'll see what happens when I try a sphere. So also I'm just going to do these all on separate sheets. So this will be solid. And then I'm just going to make a new sheet. So when we want to do a new run, we just clear this. I'm going to put my solid sphere up here, which is my pool wall. And we're going to hope that we get something somewhat reasonable. Type start, hit enter, and it's not even recording right off the bat. You can see I'm getting 4 meters, which is not where the pool ball is, so I'm going to have to adjust the sensor or the position of the ball some. You can also adjust things while it's running and try to get things set up. I'm just kind of fiddling with the position of the sensor right now. I don't know why it's cutting out so much. Come on. Oop, well, I knocked my ball off of there. All right, so I have it recording at least while the ball is stationary now, which is good. So I'm gonna stop this, clear the output, type start again, and try to do my run. All right, well, in that case, what happened was the incline was actually at an angle and the ball rolled off the side, which is not what we want. And you can see we didn't really get usable data. So we're going to try that again. And I'm going to adjust the angle of the incline slightly. So you should check that your ball rolls somewhat straight down the incline. And yeah, the sensor hopefully is at least getting in the position before you release the ball. So let's see what we got for that. Yeah, so this was while I was holding it stationary still. Stationary. And then it just cuts out, I think. Like this point was probably while it was going down the incline, but we need at least a few data points, which that did not give us. So let's give this one more try. Otherwise, I'm going to just do a few tries off camera and show you whatever one is best. Like I said, this is finicky. You may have to mess with it for a while to get decent data. It is possible, but it is finicky. So let's give it one more try. Well, we got a few data points there, but not enough to really use. You can see it was at around 12 centimeters. And then somewhere around here, I released it. Or well, no, around here, I released it. And it got, 4 or 5 data points. Well, it probably got something like that. It really isn't as much as we would like. And I did get a few points down here that may be good. Let's see. I'm just gonna copy this, and we'll see exactly what it looks like. So we're gonna just make a graph again, scatter. And so you can see this is the data that was actually for the ball, as well as this. This is some other object, and this is a third object. So this is what something that cuts out a ton will look like. And, we could maybe, I guess I'll show just trying to use this. And then I'll come back with a hopefully better run. But if this, let's say this was the best you could get, I'm going to make another chart. Or actually, in this case, what might be easiest is just to select the data that we want and make a new column. So as far as good data, we're going to take this, which is just from when it started accelerating, more or less within a couple tenths of a second. So that would be like this area right here where it starts to curve up. And then we're going to take, this is one good, oh no, we've already got that one. So this at 40 centimeters, it was recording the ball again. Wait, did I get, there should be 3 of those. Make sure you get as many points as you can. So there's 3 there. And then there's 2 more down here, where it's at 50 centimeters. And so if we make a new plot and just include that data. So now what we want is this and this. And you can see that that does more or less make a parabola. So we can try fitting it, and it may give us something reasonable. Um, Obviously, this is not ideal, like I said, but we'll just show, this as a bad case of what you might have to do. So again, you're just going to use polynomial degree 2, use equation, and that is what we get. Now, theoretically, our acceleration for that should have been higher than for the last, but we can see experimentally we did not, higher than for the solid cylinder. We can see experimentally we did not actually get that. So this is not ideal, but I'll come back with hopefully some better data to show you a more ideal situation. But you may end up doing something like this. And if that's all you can get as far as the data, that's fine. I understand that this is a little bit finicky. So, all right. So for some reason, I've had much more trouble with this today than I did when I did it in the past. But I guess that's what happens when I start trying to record a video. I was not able to get anywhere close to a perfect run. What I did do though was just record several runs in a row and look at them, as groups. And so I'm going to show you what to do if you want to do that. What I did was I started recording, put the ball at the top, let it roll down a few times, and you can see this is one of the times, this is another one of the times, and this is the third one. And the third one is, I don't know. I mean, I've gotten runs about that good, but I haven't been able to get anything much better than that. But I'm just going to show you what to do if you choose to do it like this, in order to, get this into something usable. So you can see that the data I want is between about 3940 and 3945 seconds. So I'm just going to scroll down to there. And find the data that I want. So we're starting at about 8 centimeters here. And then it starts increasing. So I probably want the data from somewhere around here to where it cuts out here. And I'll take this to the top, move my chart some. So and so that's where we cut out before. Get some more good data in here, and I'm just going to copy the whole thing. I think we don't have any more good data after that. So paste this up here. This is good data. This point is bad. These 2 points are bad. The rest of that is bad. Is that really all we got? I guess so, but we'll have to use that. So I'm just gonna copy and paste this graph and change it so that it only uses the data I've selected over there. So this is now my graph, and we'll just fit that with a polynomial. And so that's what we get, which is almost exactly what we got for the cylinder for some reason. Yeah, this is not working out super well for me this time, but I guess that's an example of some problems you might run into. I had more luck with this previously, but obviously it is quite finicky. So hopefully you're able to get some data though, and the pool ball that I'm using, that should actually probably be the worst because it's moving the fastest and it's a sphere instead of a cylinder. You should be able to get good data for the cylinder like I showed, and it shouldn't matter whether that's hollow or solid. So hopefully you're able to get that done well, and then for the balls, just do the best you can.